So for 11A, you have the point 43, and you need to find the 6 trig functions of the angle theta. So as you've seen, I drew a vertical segment perpendicular to the x-axis. I've labeled the horizontal one 4 and the vertical one 3 because x is 4 and y is 3. So based on these numbers, we know that r is 5 because this is a 3, 4, 5 triangle. And so you're going to have sine of theta is y over r. Let me just put the 5 right here. So y over r, that would be 3/5. Cosine of theta is x over r, so that would be 4/5. Tangent of theta is y over x, so that would be 3/4. And then the other three are just reciprocals: cosecant, secant, cotangent. So reciprocal of 3/5, 5/3. Reciprocal of 4/5, 5/4. Reciprocal of 3/4, 4/3. Alright, so for part B, same thing. You'd have to find r. Pythagorean theorem right here. I mean, this is another Pythagorean triple, but it's not as common or as often used. The 8, 15, 17. 3, 4, 5 is more common. So you use Pythagorean theorem and take the square root of 29 and get 17. So for sine of theta, it's y over r, so negative 15 over 17. Cosine theta is x over r, so negative 8 over 17. Tangent of theta is y over x, so it's negative 15 over negative 8, but then you know that that makes it positive. Cosecant is negative 17 over 15, negative 17 over just over 8, sorry, and then 8 over 15 for cotangent. Alright, so 13a, I went ahead and used Pythagorean theorem to solve for r, and it turns out that r equals 2. So now I am going to do the sine of theta, which is y over r, negative 1/2. Cosine of theta is x over r, negative radical 3 over 2. Tangent of theta is y over x, so it's going to be negative 1 over negative radical 3. Again, that becomes positive, but then we rationalize, so this is radical 3 over 3. So this is actually a special angle. If you recognize all the ratios, they're from our our unit circle. Although it's not a unit circle, but it's the same ratio. It's just a bigger circle. But the angle is still, what would it be, like 210 degrees. Cosecant, reciprocal of sine. Secant, reciprocal of this. So this would be negative 2 radical 3 over 3. And reciprocal of tangent is cotangent, so it would be radical 3. So B, again, Pythagorean theorem to solve for r, and in this case r equals 2 radical 2. Sine theta is y over r, so it's going to be 2 over 2 radical 2. That reduces to 1 over radical 2, and so that means it's radical 2 over 2. So that's one of our special angles also. It's not a unit circle, but it's still, the angle is still, a 45-degree angle. So it's 135. Cosine would be x over r. Again, the 2's cancel, and you're left with negative radical 2 over 2 when you rationalize. And tangent is y over x. Okay, and then cosecant, secant, cotangent. So the reciprocal of 1 over radical 2 is radical 2. Reciprocal of negative 1 over radical 2 is negative radical 2. Reciprocal of negative 1 is negative 1. Alright, so 15, notice I did not draw the triangle. I just used x squared plus y squared equals r squared, knowing that r will always be positive. And so it turns out that r is 25 after going through the Pythagorean theorem. So sine theta is y over r, and remember this is x, this is y, so 24 over 25. Cosine of theta is x over r, 7 over 25. Tangent of theta is y over x, 24 over 7. And then the reciprocals, 25 over 24, and then 25 over 7, and then 7 over 24. Alright, so 17 is another Pythagorean triple. 5, 12, 13. Again, 3, 4, 5 is the most common, and then followed by 5, 12, 13. 7, 24, 25 is another one, but not as common probably. So sine theta is y over r, so r turned out to be 13. So that would give you negative 12 over 13. Cosine theta is x over r, that's 5 over 13. Tangent theta is y over x, negative 12 over 5. We're going to take the reciprocal of these three. Cosecant would be negative 13 over 12. Secant would be 13 over 5. And cotangent would be negative 5 over 12. Alright, so 19, Pythagorean theorem. When you square it, negative radical 21, you get 21. Plus 4 is 25, and then that gives you r equals 5. So sine is y over r, so that's 2 over 5. Cosine is x over r, so that's negative radical 21 over 5. And tangent is y over x, so that's going to be 2 over negative radical 21. So when you rationalize this, you get negative 2, let me just erase this, get out of the way a little bit, negative 2 radical 21 over 21. That's after you rationalize. Can you write cotangent here real fast? Cosecant, reciprocal of 2/5, 5/2. Secant, reciprocal of negative radical 21 over 5 would give you this, and then we have to rationalize it. So then that gives me negative 5 radical 21 over 21. And then the reciprocal of tangent, negative radical 21 over 2. Now I am taking the reciprocal of this one instead of this one, because if you do this, if you use this one, it's just one step. Just flip it and you're done. Okay, so for 21, after doing the, applying the Pythagorean theorem and solving for r, we got square root of 164 equals r, and 64 is 4 times 41, so the 4 comes out as a 2, and the 41 is a prime number, so it stays inside. And so now we're going to do the ratios. This is the 6 trig ratio. So sine theta is y over r, so negative 8 over 2 square root of 41. I'm going to rationalize it and at the same time reduce the 8 over 2. So this is 4 and this is 1. So it's negative 4 radical 41 over 41. Cosine is x over r. Negative 10 over 2 radical 41. Same thing, I'm going to reduce the 10 and the 2. So this is 5 and this is 1. And so that gives me negative 5 radical 41 over 41. Tangent theta, y over x, so negative 8 over negative 10, which gives you 4 over 5. Okay. Cosecant, I'm going to take reciprocal of sine, so what I'm going to do is I'm going to take the reciprocal of this one that's already reduced. So that's negative square root of 41 over 4. Same thing with cosine, negative square root of 41 over 5, and then 5 over 4. So sine theta is negative in quadrants 3 and 4, and cosine theta is negative, because that's what less than 0 means. It's negative in quadrants 2 and 3. So the 2 dots are in quadrant 3, so that means that theta is in quadrant 3. Alright, so for 25, quadrants where cotangent theta is positive, remember it's the same quadrants as where tangent theta is positive, so that would be quadrant 1 and quadrant 3. For cosine theta positive, that would be quadrant 1 and quadrant 4. So the 2 dots are here in quadrant 1, so the theta is in quadrant 1. So for 27, the ratio for sine theta is 3 over 5, so it could have been in quadrants 1 or 2. but then they told you that it's in quadrant 2, so that's why I drew the angle in quadrant 2, the theta. Sine is y over r, so that means that this is 3 and this is 5. Okay, 3, y over r. So we're missing the x measurement. Now remember, the distance is positive, but the sign gives you the direction, so negative 4. This is a 3, 4, 5 triangle. So now you have to find the 6 functions. So 3/5 sine was given to you. Cosine is x over r, so negative 4 over 5. Tangent is y over x, so that would be 3 over negative 4. The other 3 are the reciprocals. Cosecant would be 5 over 3. Secant would be negative 5 over 4, and then cotangent would be negative 4 over 3. So for 29, the first thing we have to establish is the quadrant. Okay, so they didn't tell you on this one in which quadrant theta lies. So you have to figure it out based on the 2 pieces of information that you have. First off, tangent is negative, so that would be quadrant 2 or quadrant 4. And then the other one, sine theta, is negative. Sine theta is less than 0, so that would be 3 or 4. So both conditions are satisfied in quadrant 4. So that's where you're going to draw your theta. Quadrant 4 uses this, and this is theta. Okay, so that means that I should probably draw it a little bit bigger. So we're going to go like that, right angle. Tangent is y over x. So the y is negative because it's in quadrant 4, so negative 15. And the x is positive, okay, because it's in quadrant, again, quadrant 4. So now we have to find the r value. So if you look earlier to an earlier problem, we had the same numbers, and it turns out that r is 17. So sine is y over r, so negative 15 over 17. Cosine is x over r, so that's 8 over 17. Tangent was given to you. Cosecant is the reciprocal of sine. Secant reciprocal of cosine. And cotangent reciprocal of tangent. So in number 31, they tell you that theta is, secant theta is negative 2. So we know that secant is a reciprocal of cosine. So we know the angle is either in quadrants 2 or 3. And then the second statement there, that theta is between 0 and pi. So that's either 1 or 2. So the 2 conditions are satisfied in quadrant 2. So that's where the angle is located. So just sketch it. So here you draw and this is your theta. Draw the perpendicular to the x-axis. Secant is r over x because it's a reciprocal of cosine. And remember, r is always positive, so this is 2. And then x would then be negative 1. And Pythagorean theorem, negative 1 squared plus y squared equals 2 squared. So that's going to give me 1, 4 on the other side. Y squared is 3, so y is radical 3. Okay? And again, these are ratios of a special angle. Of the special angles, it's not a unit circle, but the ratios are the same as for one of our special angles. So this one's going to be a 120 degree angle. Let's see. So sine theta. So sine is y over r. Cosine is x over r. Tangent is y over x. Cosecant is the reciprocal of sine, so 2 over radical 3, and we rationalize it, 2 radical 3 over 3. Cosecant was given to you, secant theta. Cotangent theta, reciprocal of radical 3. There you have it. So 33, tangent theta is undefined. That happens at 270 degrees, so we'll use the point 0, negative 1, so r is 1. So sine theta is negative 1. Cosine theta is 0, because 0 over r. and then you just take the reciprocals, and this would be 0.